Okay, today we are going to talk about how to solve a one-step equation. This is stuff that you've done back in 6th grade, but it might have been a while since you did things like this. So a one-step equation will look something like this. 3x equals 12, and we need to get x by itself. There are a bunch of ways for people to think about how to solve these. However you like to think about it, that's great. I'm going to show you my favorite way. I like to imagine that this is a wall, and that whatever I do on one side of the wall, I have to do the exact same thing on the other side of the wall. So my goal is to get x by itself. So I have 3, and then there's an invisible multiplication sign. So I have 3 times x. In order to get rid of the 3, I need to do the opposite operation, which means I need to divide by 3. Well, remember this wall means whatever I do on one side, I have to do on the other also. So if I divide by 3 here, I have to do also divide by 3 here. So 3 divided by 3 is actually 1 times x, but 1 times x is just x. So we really don't ever write the 1 in front of it. Okay? Then 12 divided by 3 is 4, and this wall also means equals. So our answer is x equals 4. Sometimes we have to be a little bit careful. Maybe we have something like this. And I always start with my wall. That just reminds me where the equal sign is, helps me keep track, like keep everything lined up in order. Now here, some people might think, oh, we're going to subtract. So the opposite is +4. That is not correct. The opposite's not +4. You always look right in between the number and the letter. So that means I have to look right here. That negative minus sign is not right there. There's an invisible multiplication sign. So the opposite of multiply is divide by -4, because I'm trying to get rid of this whole thing. So I divide by -4. Whatever I do on one side, I have to do the exact same thing on the other also. So I divide by -4. So -4 divided by -4 is actually 1y. But again, we don't actually write the 1, so it's just a y, equals 20 divided by -4 is -5. Now, these are both examples with multiplication, but they don't always look like that. Sometimes we might have something like a divided by 3 equals 6. I want to get a by itself, so I'm going to draw my wall, reminding me that whatever I do on one side of the wall, I have to do on the other side of the wall. And helping me keep my work straight and in order. Well, it looks like a fraction, but it's also a divide symbol. So the opposite of divide is multiply. So I'm going to multiply times 3. So now I have a 3 up top above this fraction line or the divide sign. And then there's a 3 underneath or below. So now you have 3 divided by 3. Well, and we know 3 divided by 3 is 1 times a. But again, same as we've said before, we don't actually write the 1. But because I multiplied by 3 on one side, I have to multiply by 3 on the other side. And 6 times 3 is 18. So then I get a equals 18. Another example of that, let's try maybe b divided by -2 equals 7. I like to do the wall. The wall, that's not like a mathematical thing, that's just my preference. Now, some people might think, oh, look, it's a minus, so I'm going to do +2 on both sides. That is not correct. We have to look right in between the number and the letter. What's right in between the number and the letter? It is this, which looks like a fraction, but a fraction is also dividing. So I have b divided by -2. So I need to multiply by -2. So that now there's a -2 on the top of the fraction or at the beginning of the divide, and there's a -2 at the bottom or at the end of the divide. So then I have -2 divided by -2, which is 1b, which is just b. And if I multiplied by -2 on one side, I have to multiply by -2 on the other side. And 7 times -2 is -14. So now you've seen some at the beginning with multiplication and then with division. And now we could have something like this. J plus 3 equals 8. I'm going to draw my wall. I look at the sign right in between the letter and the number, which is a plus. The opposite of a plus is a minus, so I subtract 3 on both sides. And j, here I should point out 3 minus 3 is 0. So I don't have to write anything. So j equals 5. Okay, I might have something like this. 7 plus y equals 8. Oh, I did 8 again. That's okay. Now here, there's a plus in between the 7 and the y, but I can't write minus y because I'm trying to get y by itself. So instead, I'm going to look at, I'm trying to get rid of this 7. Well, it's a positive 7. So what's the opposite of a positive 7? It's a negative 7. So there's my wall to remind me I do the same thing on both sides. So now y equals 1. Let's try one more like this. What if we have negative 6 plus h equals 2? Okay, well, I can't do minus h on both sides because I'm trying to get h by itself. So I'm going to draw that wall. And now I'm trying to get rid of the negative 6. So instead of saying, well, I'm going to do minus h on both sides because that's not going to work, I can't do minus 6 on both sides. But I could do the opposite of a negative 6 because really that's what we're always doing is the opposite operation. So the opposite of a negative 6 is a plus 6. I'm going to do plus 6 on both sides. So negative 6 plus 6, that is 0, so it's gone, and the only thing left is h equals 8. Okay, so now we've tried multiplication, division, and addition, and now there's just one more. Let's say we have something like this. C minus 2 equals 11. I'm going to go ahead and draw my wall. And because I have a minus 2, the opposite operation is plus 2 on both sides. And C equals 13. Now, sometimes you might see this next one, and this is a little tricky. And this will be our last example. Whew, long video. Okay. What if we have something like 8 minus x equals 2? Well, I draw my wall first. I want to get this x by itself. So in order to get the x by itself, I do the opposite of an 8. This is a positive 8. So what is the opposite of a positive 8? It's a negative 8, or minus 8. Okay, I'm going to subtract 8 on both sides. Well, now this gets rid of that 8, but it did not get rid of this minus sign. I still have this negative x equals 2 minus 8 is negative 6. But we're not done. We want just plain old x. So our last step is to realize that if a negative x is a negative 6, then we have to change the sign on both sides. So if I got rid of the negative here, I have to also get rid of the negative here, and the positive x becomes a positive 6.